Welcome you all on my YouTube channel Mathematics for All. So in this section we are going to discuss 5 questions related to analytic function from the complex analysis. So here I have selected the questions that are very useful for the preparation of the examination of BSc, MSc and BTech examinations. So if you have not subscribed yet, you can subscribe our channel for more updated videos. This is Brajesh Kumar Jha from Department of Mathematics. So now we can check the question one by one. So let's see the question number 1. So now take the first question from the analytic function. So that the function e to the power x cos y plus I sin y is an analytic function. And then find its derivative. So as you know, a function is said to be analytic if it is differentiable at a point and in its neighborhood. Then the function fz, that we can write fz is said to be analytic. So once we have to prove the function is analytic, we have to use the CR equation. So the real and imaginary part that will satisfy the CR equation, and the partial derivative that we have ux, uy, vx, by all are continuous. So the CR equation that you write here, ux is equals to by and uy is equals to minus of vx. So the first condition that we have to satisfy that this CR equation, and the second condition that all the partial derivative was continuous. Then the function is said to be analytic function. So here now we can go for the solution. We have given here fz, that is z is equals to x plus y. It is e to the power x cos y plus I sin y. So what we can write here, fz is equals to that we know u plus iv. So by comparing the real and imaginary part, what we get, u is equals to e to the power x cos y and v is equals to e to the power x sin y. So now we go for the first step to get the partial derivative. So the first partial derivative, that is del u by del x, or you can write in this form also. It is what? It is e to the power x cos y. And then del u upon del y, that is uy. This can be, okay, so partial derivative with respect to y only, x will be the constant. So it will be minus e to the power x sin y. Derivative of cos y is what? Minus sin y. Same way, we go for the vx. So vx will be what? E to the power x sin y only. And by, it will be e to the power x cos y. So now you can check here, del u upon del x is equals to del v upon del y. These are to the same. So the CR equation that we have, ux is equals to by, and that is e to the power x cos y, that we can write. Same way, uy is what? Uy is minus e to the power x sin y, and vx is e to the power x sin y. So uy can be written as minus of vx, and it can be written as here, it is equals to minus e to the power x sin y. So the first condition satisfied. So what we can write here, the CR equation, the CR equations are satisfied. So the first condition that we have checked here. Now, as you know, the fz that we can write here, the partial derivative that we have ux, uy, vx and vy, you can see all are continuous. So it is a combination of exponential and the trigonometrical function, so that you can derive in the polynomial function as well. So it is a continuous. So you have the analytic function, the given fz. Therefore, fz, given fz is equals to e to the power x cos y plus I sin y is an analytic function. Now we move to the second part, find its derivative. So the second part we have, part 2, that we require to find the derivative. So fz, that we know, it can be written as u plus iv, and it is given as e to the power x cos y plus I sin y. And also, you know, del u upon del x, that is e to the power x cos y, so it is e to the power x cos y that we can write, and del v upon del x is also e to the power x sin y. So the f dash z, the derivative of fz, that is f dash z, can be written as in the form of del u by del x plus I del v by del x. So this will be equals to e to the power x cos y plus I e to the power x sin y. So this f dash z can be written as e to the power x, that you can take common, and the remaining was cos y plus I sin y that we can write. So you know, cos y plus I sin y, it is what? It is e to the power iy. So finally you get e to the power x plus iy. And you know x plus iy is z. So the derivative is what? E to the power z. Thus, which is the required derivative. So for the definition, you can see the previous video of analytic function. Now check the second question. Okay, now come to the second question. So that derivative of z bar, that can be does not exist anywhere, or another way we can say that fz is equal to z bar is not analytic anywhere. So again we will use the same formula of derivative here. So in the solution, what we can write, the d by dz of fz, it can be written by the definition limit del z tends to 0, f of z plus del z minus f of z upon del z. So this can be written in this way: limit del z tends to 0, f of z plus del z. So fz is z bar, so it can be written as z plus del z bar minus z bar upon del z. Okay, since z is equals to x plus iy, so z bar will be what? X minus iy, and del z will be del x plus I del y. So del z bar will also can be written as del x minus I del y. So having this rough work that we can see, otherwise you can write in the answer also. So it will be del z tends to 0. Okay, so you know z1 plus z2 bar can be written as z1 bar plus z2 bar plus or minus. So in this way z bar that we can write. So it can be written as z bar plus del z bar minus z bar upon del z. So ultimately it will be what? Limit del z tends to 0, and it will be del z bar upon del z. So what we have in the expansion of del z, so it will be del z tends to 0, so it will be del x plus I del y, sorry, minus I del xy del y, and it will be del x plus I del y. Here we will choose the path along x-axis and the y-axis. So along x-axis, what we see, del y will be 0. So in that case, okay, del z tends to 0 means what? Del x plus I del y also tends to 0. So del x and del y both tends to 0. So that we can write limit del x tends to 0, del y tends to 0, and here del x minus I del y upon del x plus I del y. So by choosing this path, del y will be 0. So it can be written as limit del x tends to 0. It will be del x upon del x, and you get here what? 1. Now select the second part, the second way, that is the what? Along y-axis. So along y-axis we know del x will be 0. So in that case, your f dash z is what? It is limit del x tends to 0, del y tends to 0. It will be del x minus I del y upon del x plus I del y. So along y-axis that we are defining here, so it can be written as limit del y tends to 0, del x will be 0, so it is minus I del y upon I del y. So by putting it, solving, it is minus 1. So what we can say that as del z tends to 0, but the limit of derivative does not exist. This is not matching here in the two-way. So the derivative does not exist. Derivative does not exist. Hence, we can say that fz is equals to z bar is non-analytic. Non-analytic anywhere. Or we can say it is not analytic. So this is the answer of our second question. So the next question we have, construct an analytic function fz whose real part is e to the power x cos y. So real part is given here. So in solution, what we can write, fz is what? It is u, let's say xy plus I v of xy. So a real part is given. So u of xy is given. It is e to the power x cos y, and we need to construct the analytic function. So if we are willing to construct analytic function, it means what? We required v of xy. So to get this, what we do, first we have the partial derivative of u. So the first partial derivative del u upon del x, it will be, by keeping cos y constant, it will be e to the power x cos y. And the second derivative del u upon del y, it can be written as minus e to the power x sin y, because derivative of cos y is what? Minus sin y. Now we can write here, we know that dv will be what? It will be del v upon del x dx plus del v upon del y dy. So it can be written as, okay, del v upon del x, using the CR equation, del v upon del x is what? It is minus of del u upon del y. So it is minus of del u upon del y and dx, and del v upon del y is what? Plus of del u upon del x. So del u upon del x dy, that we can write. So here we have used the CR equation. So by using CR equation, what we do here, so dv can be written as minus del u upon del y. So minus minus, it will be plus e to the power x sin y dx plus del u upon del x e to the power x cos y dy. So integrating both sides, integration of dv is the v, it can be e to the power x sin y dx plus integration e to the power x cos y dy. So it will be v, and integration with respect to x, so what we can write here, it will be e to the power x sin y. And in this case we have to ignore the term containing x. So either we can put here 0, so we have v is equals to e to the power x sin y. If you are integrating again, so it will be what? E to the power x sin y. So both way we can get here. So you must go to the find how to get analytic function. So term containing x, that will be ignored here. So b is equals to e to the power xy, that we get here. So fz is equals to u plus iv, that we know. So it can be written as e to the power x cos y plus I e to the power x sin y. So it can be taken as e to the power x is common, so cos y plus I sin y. So it can be written as e to the power x e to the power iy. It can be written as e to the power x plus iy. So e to the power z. So fz is equals to e to the power z is the right answer. So this is the another way to get the analytic function. Now the question 3 again we can solve in the another way. So what we do in that case, we find the partial derivative. So u is given e to the power x cos y. So we can get the partial derivative del u by del x, that is e to the power x cos y, and del u upon del y, that is minus of e to the power x sin y. So we know that del u by del x is what? Del v upon del y, and that is e to the power x cos y, using again CR equation. So now what we can write, del v upon del y, that we have e to the power x cos y. So it can be written as del v is equals to e to the power x cos y dy. Or by integrating, what we can write here, b is equals to, so once we integrate it, it is going to be e to the power x uh, sin y plus c. So to check the value of c, again we can write del b upon del x. So del b upon del x will be what? E to the power x sin y and plus 0 that we can get. So once we compare with the del b upon del x is what? It is minus del u upon del y. So it is e to the power x sin y. So here the term is, okay, you are integrating with respect to y, so it will be the function of x. So it will be f dash x that we can write. So what we can get here, f dash x is equals to 0. So derivative of f is 0. In that case, f of x is what? It is nothing, it is a constant. So b that you can write e to the power x sin y plus c. So in that case, your fz will be u plus iv, and u is what? E to the power x cos y plus I e to the power x sin y plus ic that we can write. So this combination can be written as e to the power z plus ic is also constant c1 that we can write. So once you get the derivative, this term will be 0. So this is the another way to get the analytic function. Now we can check the question number 4. Discuss the analyticity of the function fz is equals to z bar. So we are checking the analyticity at the z bar. So whenever you have z bar, that is x minus iy, so it will satisfy the condition, that is the limit condition at only z is equals to 0. That you must remember. So we are checking here z is equals to 0 that we are talking about. So here it is a combination of z bar. So in the solution, what we have given here, fz is z bar. So that can be written as fz is equals to x plus iy, and z bar will be x minus iy. So once you multiply it, it will be what? X square plus y square. So fz is what? It is u plus iv. So only u is there. U is what? X square plus y square. And v is 0. So to check the CR equation, what we do here we check the CR equations at z is equals to 0. At z is equals to 0 means what? X is equals to 0 and y is equals to 0. That we must remember. So to check this, what we get at the origin, in other words, what we say at the origin. So in that case, del u by del x will be written as limit h tends to 0 u of 0 plus h into 0 minus u 0 0 divided by h that we can write. So we are having the partial derivative with respect to x, so that it is u 0 plus h. So it will be equals to limit h tends to 0. Okay, u 0 plus h 0 0. So by putting this, you will get here h square by h. So it is equals to 0 that we get. Similarly, if we go for del u upon del y, so it will be what? Again, limit h tends to 0, u 0 0 plus h minus u 0 0 upon h that we can write, or in the place of h we are taking partial derivative with respect to y, so you can write down here k, and k tends to 0. Again, if you put this value in the x square plus y square, what we get, it will be limit k tends to 0 and it will be k square by k. Hence, it is again 0. Now, v is already 0. So, directly that we can write del v upon del x is equals to del v upon del y, all are 0. So in that case, if we go for the CR equation, that is del u by del x is equals to del v upon del y. So both are 0. So it is equals to, it satisfies first condition. Now del u upon del y is equals to minus of del v by del x. So this is also satisfied. So what we can write here, hence CR equations are satisfied. Where? Satisfied at origin. Now what we got here, the CR equation satisfied here. Now we have to show that this derivative exists and continuous here. So what we do here now, we find the partial derivative f dash at z is equals to 0. So it will be equals to limit z tends to 0 f of z minus f of 0 upon z. So you know fz is what? X square plus y square. So it can be written as limit z tends to 0 x square plus y square, and f0 is what? It is 0 upon x plus iy. So now we can consider here, let z tends to 0 along the line y is equals to mx. So in that case, what we can write, f dash 0, that will equals to limit z tends to 0 or y is equals to mx, that you are writing. So directly we can write x tends to 0 and x square plus y square. So it will be x square plus y is equals to mx. So it is m square x square upon x plus I mx, that we can write. Now what we see, the x, one x is the common, so that will be neglected here. So what we get here, limit x tends to 0, it will be x plus m square x upon 1 plus I m. Or by taking the common x in the numerator, what we get, limit x tends to 0, x into 1 plus m square upon 1 plus im. So by putting the limit, this term is going to be 0. So therefore, what we get here, f dash 0 is unique. Hence, the given function fz is equals to z bar is analytic at z is equals to 0, which is the required answer. Now for today's discussion, we can move to the question number 5. Now we will take the last question of this section, that is discuss the analyticity of the function fz is equals to e to the power I z bar. So as we can see here, z is equals to x plus iy, that we know. So z bar will be x minus iy. So what we have given the function, first we simplify it. So fz is equals to e to the power I z bar. That can be written as here fz is equals to e to the power I x minus iy. So it can be written as e to the power ix plus y. So we can write y plus ix. It will be equals to e to the power y, and e to the power ix, that we can write cos x plus I sin x. So separating in real and imaginary part, fz is what? U plus iv, and it will be e to the power y cos x plus I e to the power y sin x. So here we get y is equals to e to the power y cos x, and v is equals to e to the power y sin x. So to check the whether function is analytic or not, what we do here, we go for the CR equations. So to check the CR equation whether it is satisfying or not, we will have the partial derivative. So ux will be what? Minus e to the power y sin x, differentiation of cos x, and vx will be what? E to the power y sin x. Uy, it will be e to the power y cos x, and vy will be e to the power y sin x. As we know from the CR equation discussed earlier also, CR equations are ux is equals to vy and uy is equals to minus of vx. So as we can see in this derivation, CR equation does not satisfy it. For any values of x and y. So if it is satisfying for any value, let's say x is equals to 0, y is equals to 0, then we can check. But here it is not satisfying for any value of x and y. So in that case, what we can see, the CR equations are not satisfied for any value of z. Hence, fz is equals to e to the power I z bar is nowhere analytic. So whenever it is asked such questions whether the function is analytic or not, so if it is not analytic, you have to give only one example. Let's say z is equals to 0, that is analytic or not. In such type of questions, we need to check the points also where the function is analytic and how it's behaving. So in the upcoming lecture, again, I will come with the CR equation and the Laplace equation and some questions like u is given, then you require to v to find. So thank you for watching this video. You can like and you can subscribe. If you have not subscribed yet, then you can subscribe our channel for more updated videos, and you can share with your friends on social media, on WhatsApp as well. So thank you for watching this video.